Morning, everyone. Let's go ahead and get started.
No response.
All right, everyone. Let's go ahead and get started. My only announcement for today is that we don't have seminar next week. It is the Veterans Day holiday. Assuming this year this will be Veterans Day / election hangover holiday. So no seminar next week. The following week we will have. You should know if we have one or two. The following week we will have one PhD proposal by Mike Breedson. But this week we have Tyler Garwood joining us to give his master's proposal. Tyler comes to us from the University of Madison, Wisconsin, from the oldest wildlife program in the United States. He currently lives in Custer State Park, so we don't see him very much, but I think living in the state park sounds like a pretty awesome idea. And today he's going to be telling us about mitigating respiratory disease persistence and transmission in bighorn sheep populations. Tyler?
Great, thanks Josh. So as Josh said, I'm going to be presenting on mitigating respiratory disease persistence and transmission in bighorn sheep populations, and I'm advised by Dr. John Jenks. So I'm just going to frame my project in the larger history of bighorn sheep in the western U.S. So about the time of European contact, the upper estimate of population is about 2 million. That started declining basically upon contact, and it got down to about 40,000 around the mid-1900s. And then we've had a few recovery efforts. And so we're now up to about 80,000, but we're still having disease problems. Initially, it was market hunting and habitat loss were some big factors in why we came way down from that 2 million, and we're still a far cry from that big of a population. So disease right now, biggest problem with bighorn sheep management is contracted from domestic sheep and goats. And it can also, mountain goats can also act as reservoirs if they come in contact with those domestics. So once it does hit a population, it can take up to about 90% of the adults in that population. And then the big problem that we're really grappling with this project is that after that initial outbreak, every subsequent year you lose about 90% or you can lose up to 90% of your lamb crop. So when it hits a population, is the primary source of mortality in that population, and then you get this aging population because you don't have good recruitment. So what we found out recently is that pneumonia is really the proximate cause. They were having a lot of trouble figuring out what the pathogen was that was causing these pneumonia outbreaks. And since the 1990s, they've been documenting these huge epizootics. But then in 2008, they were able to show a strong association between Mycoplasma open pneumonia and these pneumonia deaths that were occurring. And basically, what happens with MOV is it makes the sheep susceptible to getting pneumonia because it causes their cilia to lay down in the trachea, and then they can't clear their lungs as well. So Dr. Messer in Washington State was the one who kind of figured this out, and he's one of our collaborators. So this leads to, knowing this, what do bighorn managers need? What does this project kind of aim to provide to these managers? Well, we need a cost-effective way of clearing the population of pneumonia, and ideally you don't want to have to remove the entire herd, which is something they've been doing in Montana. So, because that can be costly, and also just you don't know how well the reintroduction is going to take. So, and also just they want more evidence that it is actually MOV in these wild populations causing these outbreaks. Not some other disease. So, and then in South Dakota, we'll also be able to provide some serial samples, so if this project works, they'll know more about the disease dynamics in their populations, and then just get some mortality rates and lamb survival data. So the objectives of this project are to determine the effect of chronic shedder removal on lamb survival. So basically see, well, I should also define a chronic shedder first. A chronic shedder is basically the animal that is passing the pathogen to these lambs. So after that initial outbreak, they'll survive, but they won't really fully recover, and then so every time you test them, they show up positive, and they're always passing on these pathogens. So anyways, so we want to see if removing these shedders improves lamb survival, and we think it will. And then we also want to determine mortality sources in adults and lambs. This is important mainly because, well, if they die, we want to know what they're dying from. So if it is pneumonia, then we can document that. And then just overall, just see if it does, removing these chronic shedders does raise the raise survival in the populations. So I'm working in the Black Hills. I'm just going to give you a quick history of what's been going on there. So in 1899, all bighorn sheep were extirpated from the Black Hills. They tried reintroduction in 1922, that failed, and then they had another reintroduction in 1964, which took, and both of those were near Custer State Park. And then in 1991, they reintroduced more sheep into Rapid City area, and that took well initially, but then we started getting epizootics around the mid 2000s, and those populations have been on decline ever since. We've got 3 other herds that don't have disease problems right now in Hell Canyon, Elk Mountain, and Deadwood, but I won't be talking about those. So Custer State Park is my experimental population. This population will be manipulating. So there were 25 adults and 3 lambs when I started there, and the habitat is pretty well burned, which is good for sheep. And there's a lot of rocky outcrops in these burns, and then they'll also utilize canyons, and it's also fenced, but that doesn't seem to keep them in, as you can see from their habitat range there. So. And then my control population is in Rapid City. There's about 65 animals there. You can see it's kind of broken up into 3 different subherds here, but there is intermixing between them, not a ton, but for the purposes of this study, we're kind of considering this one big population, although we will look at differences between Rapid Creek and Spring Creek. So the habitat's interesting because it ranges from almost downtown Rapid City to outlying areas like Lake Bactola. And then it's mainly just, they live down in the canyon bottoms, so, and they'll use the steep cliffs along creeks to lamb and do other, and it's pretty actually pretty thick habitat in a lot of places. So another thing I want to mention about these 2 areas, there should be no intermixing between those 2 populations. They're separated by a good 20 miles, so there's not really good habitat for movement between. So this is a pretty intensive field study. So I'm going to break it into 2 phases. We've got adult data collection, and then the manipulation of the population, and then we've also got our lamb data collection. And I'll get into more details on that as we go. So basically, the first thing we've got to do is collar adults and get tests on adults. So we got to capture them, right? So the 2 techniques we've been using are either darting, which is less efficient but less. It's less efficient but also less costly, or helicopters, which is very efficient but costs a lot per animal. So once we do capture an adult, we will put VHF collars on them, and this will assist us in catching them again and performing those serial samples that we need to classify them. And then we'll also be monitoring them weekly for mortality. When these collars stop moving, they'll change the signal that they're sending out, and you'll know that the animal is likely dead. So when we test them, we're trying to get 4 different tests on them. We want the nasal swab test. This tells us information about the Mycoplasma pneumonia, which is the pathogen that seems to be causing these epizootics. We'll also take throat swabs, which will tell us about a disease called Pasteurella, which is thought to be one of the diseases that ends up killing the sheep, and was thought to be a disease that maybe was causing it in the past. And then we'll also take a blood draw. This is to get information on the antibodies in the sheep, and then we'll also do a nasal wash. This gives us information. Well, this will give us bacteriology information, and you can do genetic work with it too. So we send all these samples off to Tom Besser, who's that guy right there, and his lab is at Washington State University, and he'll come back to us with results for bacteriology, PCR, and titers for the antibodies. So I'm guessing lots of you are familiar with PCR, but if not, I'll just go through this real quick. We get the Mycoplasma pneumonia results back as CT values, so basically, which is cycle threshold values. So in PCR, it gets amplified like 40 times in this particular test, and that's the cutoff. So if we get a CT value back of 40, then we know it's a definite negative on that animal, on that sample. So if we get a CT value back of 35 to 40, so let's say they start seeing enough DNA at 35 or 36 to, all right, that's where the DNA starts showing up. Then we're not really that's kind of this gray zone for us. We're not really sure. It could be some contamination in the sample or some contamination like in the labs that's causing the signal to show up. But if we get a CT value below 35, we can be, and especially lower around 30, then we can be very, very confident that that animal had a positive sample. So ideally, we get 3 serial tests, and we'll look at those tests, and if any of the individuals have tested positive 3 times, then we think we'll classify them as chronic shedders, and we'll remove them. So phase 2 of this is obviously lamb data collection. So when we're catching the adults during the winter and the spring, we'll also do an ultrasound on the pregnant or on the ewes to see if they're pregnant, and then we'll if they are pregnant, we'll insert a vaginal implant transmitter in them, and this will fall out when they give birth and send us a signal that it's fallen out, indicating that a lamb is likely on the ground, and they're temperature sensitive, so that's how they change their signal. So I'll start listening for VITs every day, sometimes twice a day, starting in late March or late April, early May, and then once we hear that signal, we'll go in. We have to be there. I mean, these lambs are incredibly precocious. They can be up and running by 12 hours. They're really hard to catch. And then, so once we do catch them, though, we'll put on expandable collars, as you can see right here. So these stitches will pop as the lamb's neck grows, and eventually the collar will fall off. And then and these will operate similarly to the adult collars in that if they die and stop moving, then we'll go in and we'll know it's a mortality, and we'll go in and find them. And then we also weigh them just as a measure for condition. So once we do have a bunch of colors on the ground, we've monitored these lambs every day for mortalities, and we also want to get visuals on them, which are just so we can see how they're progressing through the disease, if they do have the disease, or just so if they do die and we can't get to the carcass right away, we have an idea of what's going on. So when we do get a lamb mortality, we'll go there as soon as possible, find the collar, and we'll do a scene investigation for possible mortality sources like caching, so that would indicate that we've got a mountain lion predation. And then once we do that, if there's enough sample, or if there's enough left of the carcass to collect, we'll take it and we'll ship it out to Washington again, this time to a slightly different lab. And then we'll get some results back from that, and they'll do a necropsy, and then we'll get a bunch of results back from that. So the histopathology, the pathology, the toxicology, and the serology. And from that, we can go ahead and be pretty certain what the cause of death was. So then we've collected all this data. We're going to use a cumulative incidence function in package wild 1 in program R to analyze the adult lamb sources of mortality. And then for adult and lamb survival, we're going to use a known fate model in program Mark to calculate that. And then to compare the lamb mortality sources between groups, we're going to use a chi-squared test with significance level of 0.04. So I've been working on this since January. So we've got a fair amount of testing done. We've gotten 74 individuals tested so far and 3 retested. We have 2 positives come back in CSP, or Custer State Park, so we removed those individuals, and we haven't had any since. We had a total of 18 positives in both study areas. And then in terms of lamb collaring, we collared 26 lambs, and we've documented 12 mortalities so far. Only one of those mortalities was in Custer State Park, and that was pretty definitively a mountain lion, or due to mountain lion predation. And then in Rapid City, we have documented pneumonia deaths. And then as far as adults go, we've had 7 mortalities total. 2 of those were in Custer State Park. The 2 in Custer State Park were mountain lion predation. And then we have, again, documented pneumonia deaths in the Rapid City herd. So just to kind of frame this as I go out, why is this important? So bighorn sheep really haven't been a significant part of the ecosystem for a long time, and having them back as a grazer would be very interesting biologically and potentially add some complexity to that system. There's also the potential for this project to benefit endangered subspecies such as the Sierra Nevada bighorn sheep, because the methodology being developed here could be applied to those populations. And then from an economic standpoint, it brings people in rural communities like Custer for the chance to see them, and then also hunting tags for bighorn sheep can be auctioned for up to $250,000. All that money goes back to bighorn sheep conservation. And then this project's also national in scope. It's not just it can be applied across the country. So Montana has a lot of these isolated mountain ranges where this might work nicely. Washington is another place, or Utah has been talking about applying this work. So the potential implications of this project are pretty big. So with that, I'd like to thank my partners and funding sources, and everyone who's helped me, my committee, my advisor, Dr. John Jenks, my technicians, and then a bunch of people who have given me advice and help from both agencies and here at Estes. And with that, I'll take some questions.
cost to ship a dead lamb next day air on UPS to be necropsied in Washington?
$500.
Wow.
Yeah, it's a lot. So at this point, we're and probably next year what we do is perform a pluck. So we just take the the respiratory tract out and send it, and I think that would cut down on the cost. Although it is nice for them to have a full necropsy to work with as well. So.
What is your plan if you don't color land in time?
So what we've been doing with that is darting, and basically, so the visuals help with that a little bit. But we've also been darting the lambs after they get a little bit older, and that helps us get full coverage. So this year in Custer, we believe we got every single lamb collar, that's kind of the important population to have covered too, because you want to know that there's absolutely no disease there. But yeah, that can lead to gaps in the data, which is why you run it through statistical analysis to hopefully get something out.
Tyler, I might have missed this, but do you know what the mortality was between the 2 study years before you started your project? So you have an idea of.
Yeah, it's a good question. I know. So as far as CSP goes, I'm not sure they actually have great numbers on that, but they do have like documented cases of pneumonia where they found a lamb carcass in the ditch or something, and they would send it out to Washington State. So really, the ultimate goal here is to try to just not have pneumonia in the population, right? So like one pneumonia would honestly be almost a failure of the project. So.
Could you just repeat the questions? And
Oh,
then
yes.
also I have my own. And could you maybe explain again your genetic analysis? I'm not entirely clear. Are we talking about a genetic difference between shedders and non-shedders? Or, yeah, maybe you could just elaborate on that.
Yeah, so I'm going to elaborate on the genetic analysis that we're using. So basically, the genetic analysis is on, what we're really looking for with this genetic analysis is it's for, well, we're not actually doing a genetic analysis on the animals, it's just the pathogen that we're looking at. So some of the things we will do with that is so we're doing the PCR, right? So that's to look at, have the genetics. I mean, does that genetic signature show up, right, when you put it through
Of the pathogen.
Yeah, right. So, yeah, and then you can also, another thing we're looking at is different strains within the pathogen. So you might have, and what we found is so each population often has a different strain, which is what makes it really, or at least, like Montana has a different strain than Nevada than South Dakota, right? So, which makes it hard to develop a vaccine, which is why we're doing removals rather than vaccinations, or part of the reason at least.
Your treatment and control populations are 2 different sizes, but your area looks to be very different too. Do you know if the densities between the 2 populations are similar?
So the question was if, are the densities between the 2 populations similar? I think it's hard to say because they're such a social animal, right? They just tend to. So they utilize, I guess they utilize parts of their habitat differently, right? So during lambing, I would say they're more spread out in like rapid creep, whereas in Custer they tend to lamb in the same area. But I don't know. I guess it's a hard. It's definitely, if you're talking about total area that we could potentially use in Rapid City, I would say density is lower probably in Rapid City than in Custer State Park.
So with regards to your amplification of the pathogens, where you're trying to get this signal, what's the error rate on this, Tyler? I mean, obviously you're being careful when you're in that gray zone, but how repeatable are these tests?
They seem to be pretty repeatable because, so one, I guess I don't know like a specific number, but we have retested a few of them, and usually it's pretty much get the same values.
So I was curious about the sample sizes that you shared at the beginning between your experimental and your control population, and then the data you presented. It seemed like you had more data than you had animals. Could you go back to that data?
Yeah.
You know what I mean? I was just kind of curious, because I had written down 25 adults and 3 lambs, and it seemed like you had a lot more action in your population.
Yeah, okay, so, I'm not sure how to rephrase that, that's a question, but. So I had 25 adults and 3 lambs in just Custer, and then I had 65 and 5 lambs.
Okay, now go to your data slide for me and help me. There you go, because I had that written down then. Because that one we went through. Progress to date.
Yeah.
Oh, okay, so this was across both populations?
Correct, yeah, yeah.
Ah.
Yeah.
So,
And we're trying to get as close to complete coverage as possible in both populations, so we are hoping to have almost as many individuals as aren't there.
so then a fifth of your population, or about, is testing positive in your control area,
Yeah, and
right?
yeah,
I'm
so a
just-
fifth of the population is testing positive, yep. And there's actually a really pretty big breakdown between Rapid Creek and Spring Creek. Like Spring Creek, I think there were 2 individuals positive, and then Rapid Creek had the 12 positive individuals. So
Okay.
there's actually, even between subherds within our control population, we're seeing different breakdowns, and that's actually being reflected in the lambs too. So all the lambs I initially had collared from that herd ended up dying in that subherd, the Rapid Creek, whereas I've still got 4 of those initial lambs, I think 8 lambs we got in Spring Creek are still alive. So it's kind of, some of the dynamics at the subherd level are fairly interesting too.
Kurt, do you happen to have any questions? I think you're the only remote person today.
Go. Hi, Josh, and I do have a question. It sounds like there's a lot of work that you're doing. How many people are you? Is it you or?
Yeah, so it's me. It depends on the time of year, I guess. So sometimes it's just me, and then sometimes I'll have like a ton of help from the Rapid City office, that's South Dakota Game Fish and Parks. And then Chad Lehman, one of my committee members, is there at Custer State Park. He can help me. And then I had Tanner was my technician this summer, and then Rachel was another technician who wasn't working technically for me. She worked for the park, but she was able to offer a lot of help too, and is still helping out a bit. And then so right now we don't have South Dakota Game Fish and Parks helping out, but we're hoping to get them back within a month or 2. So, and that definitely helps, because the study areas it takes me at least an hour to get from one study area to the other every single day. So it's just a lot of driving, a lot of gas. So when they can help out, that's huge because they're based in Rapid City.
Any other questions? All right, let's thank Tyler one more time. And one last announcement that I almost forgot about. We do have a defense on Thursday morning or early afternoon. It's not on my regular schedule, so I forgot to write it down, but it is Fred Oslin will be doing his master's defense. I sent out an email about it. I will send out another reminder in the early part of next week. But no, again, no seminar on Friday next week. Thanks, everyone.